Hi. So while we have spent enough time explaining why we think Bitcoin is a great investment opportunity, in our opinion, we also think that it is important to understand how this technology works. Understanding the technology will help you build conviction on this as an investment option and also help allay fears, common concerns that people have, such as Bitcoin is going to get hacked someday, Bitcoin is not secure, Bitcoin can be copied, Bitcoin can be manipulated, etc. And we also felt that there are not many resources out there that help people understand blockchain as a technology or how Bitcoin works in an easy to understand manner. And we want to help change that. So the idea is to give you a quick and easy overview of how this works and what makes Bitcoin so secure. And since this is no easy task, we decided to shift away from our standard conventional podcast-based conversational model to a video-based model in which we are using visual aids to explain the concept to you for a better grasp of the subject. So with that, let's get into how Bitcoin really works and what blockchain is.
So, to begin with, we wanted to call out a few basic terms that you should keep a note of. We will get into details of each of these throughout this video, but we want you to pay particular attention to these terms and understand them because they will be critical to your understanding of the overall subject. These are transactions, block, blockchain, proof of work, miner, validator, a cryptographic puzzle, and finally, miner economics and Bitcoin rewards. So what are transactions? Like financial transactions where money is exchanged between two parties, when Bitcoin is exchanged between two parties, it is also called a transaction on the Bitcoin blockchain. These transactions can be person-to-person exchange, also known as peer-to-peer, or they can be when Bitcoin is exchanged to buy goods and services with merchants that accept Bitcoin. Next up is a block. Think of a block as a folder in which you store multiple transaction records. It can contain from a few hundred to a few thousand transactions depending on the size of the transactions. And a miner is that entity who gets to create this block. And not just any miner. Only the miner who shows proof of work gets this right. And then a validator gets to validate this block for authenticity and accuracy. Moving on to a blockchain ledger. Just like a block is a collection of transactions, a blockchain or a blockchain ledger is a collection of blocks where the blocks are stacked one on top of the other. This stack of blocks represents a chain-like structure which gives the technology its name. So with that high-level understanding of the basics, let's see what the end-to-end process looks like at a high level. Step 1 is a transaction, when Bitcoin is exchanged between two parties. Step 2 is when these transactions go to a memory pool. Step 3 is when miners add transactions to a block. Step 4 is where the miners start a race to be the first one to solve a cryptographic puzzle. Step 5 is where the miner who has won the race by solving the puzzle first lets everybody know that he has won. Step 6 is where the validator validates the work of the miner who claims that he has won the race and makes sure that he is not lying to the network. In step 7, once enough validators, that is more than 51% of the validators on the network, have validated the miner's work, he gets the right to publish his block on the Bitcoin blockchain. In step 8, all network participants, that is the miners and validators, will download a copy of the new block to their local copy of the Bitcoin blockchain. Finally, for his work in publishing a new block to the Bitcoin blockchain, the miner is rewarded by the network in the form of newly minted Bitcoin. The miner can then take this new Bitcoin and sell it on an exchange in the open market, and that is how new Bitcoin comes into circulation. Okay, so let's get into the details now. Back to step 1. A transaction occurs, where Bitcoin is exchanged between two parties or someone buys something using their Bitcoin. Step 2. Memory pool. These transaction records from step 1 go into a memory pool. Think of a memory pool as a waiting area for transactions where miners come every 10 minutes to pick up the latest transactions, which is transaction verification and filling the block. Miners begin by verifying the transaction that they picked up from the memory pool. How do they do that? Well, miners have to check each transaction against a whole bunch of rules in order to verify them. These rules are related to things like timestamps of the transactions, the nature of information in the transaction details, whether all transactions have signatures or not, etc., and many other rules. Once these transactions are verified, each miner adds the transactions in a block until it is full. The block has a maximum size limit of about 1 MB, so as many transactions as can be packed into that 1 MB file size are added to the block. And please note, all miners are in parallel doing the same tasks, as all of them want to create the new block. But only the one who accomplishes the task first and accurately wins. Think of this as an assignment given to kids in a school. All of them do the same assignment, like let's say writing an essay, but only one of them will get the first prize. Step 4 now, the cryptographic puzzle. Remember how we said that the miner who accomplishes the task first wins the race for the Bitcoin reward. Now that these competing miners have all completed filling their individual blocks, the last challenge remaining in this competition is a race to solve a cryptographic puzzle. Okay, let's take a pause now. Things will get slightly more technical from here, so strap in and focus. This puzzle is not a simple puzzle that a smart human can solve. It is a complex mathematical puzzle that only very advanced computers can solve. This puzzle is also known as a cryptographic puzzle. To understand it better, we need to understand a couple of concepts: proof of work and SHA256. So in the early days of email, spamming became a huge issue because you could send millions of emails and spam people's inboxes with ads, etc. So somebody invented a concept where in order to send an email, the sender of the email would need to solve a cryptographic puzzle which could take up to 1 or 2 seconds per email before they can send the email. So now, if someone wanted to send 2 million spam emails, they now needed to spend 1 to 2 million seconds to solve the puzzles before sending the spam. 1 to 2 seconds per email does not bother legitimate users because they were not sending bulk emails. But for large spammers, the process became very hard. This basically is proof of work. By solving the puzzle, you are providing proof that you performed an activity which we are calling work before you win the right to send an email. Similarly, a Bitcoin miner needs to show proof of work by solving the puzzle before he can win the right to publish a new block on the blockchain and get rewarded for it. Let's get into SHA256, and that will also clarify what the cryptographic puzzle is. Think of SHA256 like an Excel function, like let's say the sum function. You add 2 or more cells together and the output is the sum total value of both those cells. Here, the inputs were the multiple cells and the output was the sum total value. This output was predictable, meaning you knew that if the input values were 2 and 4, the output would be 6 beforehand. Similarly, SHA256 is a function in which you can enter any input and it will generate an output. But this output is not predictable. It is completely random. In fact, it is always a 64-character long alphanumeric jumble, irrespective of the length of the input. Now let's visualize this. When we take an input, and the input can be of any length or type. It can be a text-based character, a sentence, a paragraph, or an entire file. Through the SHA256 function, it will generate an output. This output will always be 64 characters long, it will be random and completely unpredictable, and it will be the same for the same input. Using the example of the word hello as an input, we see that when it runs through the SHA256 function, it generates a completely random and unpredictable 64-character long alphanumeric code, which is also known as the hash code. This random 64-character code now becomes the unique signature for the word hello. Remember, we said that the output will always be the same for the same input. Now let's see what happens when we change the input. So we change the word hello to the word yellow. We only change one character in the input. Now does that mean that there will be only one character changing in the output? No. The output is completely different and completely random this time. So let's put things into context. Because SHA256 creates a unique, random, but consistent output for the same input always, it can be used as a signature to verify the authenticity of anything. Let's say you have a document in a PDF. You take that PDF, you throw it through the SHA256 function, and the output generated will always be the same as long as the PDF remains the same. So that is a great way of verifying that the document you are looking at is the original and was not tampered with. So now, if we run an entire block of transactions through SHA256, it should also have a distinct and unique output. And this is how we verify the authenticity of an entire block and all the transactions inside it. If you can change even a single transaction value, the entire output will change.
So now, what is the puzzle? Well, the puzzle is that the Bitcoin protocol or software asks the miner to produce a specific SHA256 hash output. For example, produce a hash output that begins with 20 leading zeros. Now, considering what you understand of the SHA256 output, which is completely random, what do you think are the chances that the first digit is going to be a zero? What are the chances that the first two digits are going to be a zero? And what are the chances that the first 20 digits are going to be a zero? And what inputs should the miner use to generate this output? Well, even that is defined by the protocol. Moving on to how miners use SHA256 to solve this puzzle in order to win the race. For example, the Bitcoin protocol tells the miner that if you want to win the right to publish a new block, first solve this cryptographic puzzle for me, where your input should be two things. One, the block header, which is a hash of two components itself. The first component being a hash of all the transactions in this new block, and the second component being a similar hash of the previous block. And number two, a random number called nonce. These would be the two inputs. And the output should be a resultant hash function that starts with 20 zeros. Now, because the block header and the output are fixed values, the only variable in this equation is the nonce, which is a number that the miner has to keep trying one by one till he gets the desired hash output that has 20 leading zeros. The only way to find such a number is by randomly trying all combinations, which takes time and computing power, not something a human can do. The first miner to find the right nonce gets the right to create a new block. For some perspective, all the mining equipment out there is producing a hash rates in the hundreds of quadrillion combinations per second, and still it takes on an average about 10 minutes to find the right hash. This makes mining an expensive and energy-intensive exercise. Once a miner finds the right nonce, he sends out a message on the network declaring that he has won the race. Now begins the role of the validators, as someone needs to validate that the miner is not lying. By the way, a validator can be a competing miner on the network, or it can be someone who does not mine and is only participating on the network as a validator. The validators
check for two things primarily. Number one, did the miner build the block by abiding to the consensus rules, which is things like transactions are stored in a certain order, did the transactions include proper signatures, etc., etc. And number two, did he really get the correct nonce? Which they can simply verify by running the input. That is the fixed block header that everybody knows and the nonce that the miner provides, and run it through the SHA256 function and see if the result has 20 leading zeros. Remember, the only way a validator can independently validate the work of a miner is if he also has a copy of the entire blockchain ledger. This is where the decentralized properties of the blockchain ledger start to make sense. Once multiple validators on the network validate the miner's work, he is given the permission to publish his newly created block to the Bitcoin blockchain ledger. After this, all network participants like the miners and validators update and make a copy of the newly published block on their local versions of the blockchain ledger, so as to keep the records distributed and decentralized. Important to note here is that no single network participant is responsible for keeping the latest update in a single database. Everyone has a copy, so that no single party can ever lie. Finally, for their efforts in solving the cryptographic puzzle and publishing a new block to the blockchain ledger, the Bitcoin protocol rewards the miner with newly minted Bitcoin. And this happens every 10 minutes when a new block is published to the blockchain ledger. The Bitcoin miner can then take this newly issued Bitcoin to a marketplace like an exchange and sell it for dollars, in turn making profits for their business.
Okay, so how was it? I really hope you enjoyed it. We tried something different this time, and hopefully you found value in it. If you liked it, maybe you can smash the like button and maybe subscribe to our channel if you're listening to this on YouTube. We're trying to help people understand how Bitcoin, how blockchain, how cryptocurrencies work. And yeah, I mean, this content is mostly free, and the only thing that we ask of is that you like our content, subscribe to our content. That's the only thing that you can do for us as a viewer and support us. Thank you.